So today we will introduce a simple and powerful approach to building classifiers. It's called the generative approach, and it's based on probability distributions. So the main idea with the generative approach is to fit each class separately with a probability distribution. Okay, so for example, here we have a training set of about 15 to 20 points. And what we do is that we first look only at one label. So here there are two labels, pluses and minuses. So we start by looking just at the pluses and we fit a model to them. And then we look only at the minuses and we fit a model to those. So maybe we get something like this. Okay, so on the left we have an ellipse-shaped distribution that we fit to the pluses. And then we have another ellipse-shaped distribution that we fitted to the minuses. That's it for the learning process. Now, when a new point comes along, say a point like this, and we want to classify it, we just ask ourselves, was this new point more likely to have come from the red distribution or the blue distribution? Under which of these two distributions does it have higher probability? And that's it. Okay, so that's a high-level overview of the generative approach. So let's be a little bit more concrete and put down some details. Okay, so here's a picture in which there are three classes or three labels. Let's call them 1, 2, and 3. So the label space Y is just the set 1, 2, and 3. And let's say that the data is very simple. The data just has one feature. So the data points are one-dimensional, and they can just be plotted on the line. So in order to fit a generative model, what we do is we take our training set, and first we look only at the points whose label is 1, and we fit a probability distribution to them. So maybe, for example, we get this distribution over here, the red one. Okay, let's call that P1 of x, the distribution for label 1. Then we take the training set again and look only at the points whose label is 2, and we fit a probability distribution to those. Maybe that looks like P2 of x over here. And finally, we look at the remaining points, the ones that have label 3, and we fit a probability distribution to that. So that's P3 of x. And now we have these three separate probability distributions. We need a little bit more information as well. Let's say, for instance, that label 1 makes up 10% of the training set. Okay, so out of the training points, 1/10 of them have label 1. So what we'll do is we'll say pi 1 equals 10% or 0.1. Let's say label 2 makes up 50% of the training set. So we'll say pi 2 equals 50% or 0.5. And the remaining 40% of the training set comes from label 3. So we say pi 3 equals 0.4. Now, at the end of this, what we have is the following pieces of information. For each class J, so J is 1, 2, or 3, we have the probability of that class, which is just a number, like 0.1 or 0.5 or 0.4. And we also have the distribution of data in that class, which is what we've been calling P sub J, P sub 1, P sub 2, and P sub 3. And these pieces of information are enough to fully specify the joint distribution between x and y. So the probability of any pair xy is the probability of that label, y, times the probability of seeing data x under that label y. So the probability of x given y. Now the probability of seeing label y is simply pi sub y. And the probability of seeing point x under the distribution of label y is P sub y of x. So we have the full probability distribution over x and y. So now a new point x comes along and we want to classify it. We want to determine a label y for it. Which label do we pick? Well, the most likely label, the one that maximizes the probability of x and y. Concretely, what we would do in this case with three classes is that we take our point x and we calculate pi 1 times p1 of x. That's some number. We calculate pi2 times p2 of x, and we calculate pi3 times p3 of x. And we take whichever of these is the largest. If the last one is the largest, for example, we'd say the label equals 3. Okay, so that's it for a high-level overview of the generative approach to classification. Some of the details might seem a little mysterious at this point because they rest on various probabilistic concepts. So what we'll do next is to do a little bit of a review, a little bit of a tour of the relevant probability, and then we'll come back and we'll flesh out this approach and see it in action.